Welcome to Study Loop.
Okay, our question says that a hunter aimed directly at a target on the same level that is 68 meters away. Then A, if the bullet leaves the gun at a speed 175 meters per second, by how much will it miss the target? And B, at what angle should the gun be aimed so that the target is hit? Okay, so I wrote down what we were given here, both directly and indirectly, and that is that the distance, which I write as x, that the target is 68 meters. The velocity in the x direction, since the hunter fires in the direction of the target, is 175 meters per second. There's no velocity in the y direction because he shoots directly at the target. And we're going to assume that the target, which is at the same level as the barrel of the gun, is our starting point for y. And that's going to be y sub 0. And we're going to call that 0, right? We're going to say that's at the origin. And we want to, so clearly it's going to drop then because of gravity. We want to know how much it's going to drop over that distance and so far, how far away from the target it's going to be because of that drop. And so in order to do that, we can go ahead and make use of the formula y is equal to y naught plus the initial velocity in the y direction via y0 times the time. Okay, and since y is in units of distance, v of y times the time also gives you units of distance. So we also will have plus 1/2 acceleration in the y direction times t squared. Again, acceleration is meters per second squared times t squared gets you back to units of distance. So we have the correct units in all of these cases. Okay, so we have in this equation y of 0. We already know that. We have vy of 0. We know a of y is the acceleration in the y direction is gravity, right? And y is what we're trying to find. The only thing we don't have yet is time, but we have all the values we need to find the amount of time it's going to be in the air because x is 68 meters, right? And v is 175 meters per second. Well, the distance something travels is equal to the velocity that it's traveling at times the time. So the time it takes for it to get to the target and the time it will have in order to drop a certain distance is going to be that time t. So if we solve for t here, we have t is equal to x, the distance, divided by v of x, the velocity in the x direction, okay, which is going to be equal to 68 meters divided by 175 meters per second. So that's going to give us a units of seconds. Okay. If you do this calculation, you find this comes out to be 0.3886 units of seconds. Okay. So now we can plug all the things we know into this equation for y. We can solve for y. By the way, this is part A that we're working on here, so let's denote this as part A. So y is equal to, y naught is 0, v of y is 0, so 0 times z is 0, plus 1/2. Okay, a of y, well, that's minus 9.8. meters per second squared. And then we just found t, right? And that was 0.3886 seconds. And then that's also squared, okay? So if you do this, you find this comes out to be minus 0.740 meters. So it lands 0.740 meters below the target. That's how far it misses it by. Okay, so now the question is, what angle would we need to use in order for it not to miss the target by that much? Okay, well, we know the range it travels, right? That's x. So we could use the range formula here to find the angle, because in the range formula we have angle. And we know everything else in this formula except for angle. So the formula for range is r is equal to v naught squared sine of 2 theta divided by gravity. Okay, so we want to solve for theta. So let's leave this sine 2 theta. Let's try to isolate theta is equal to r times g divided by v of 0 squared. Okay, so now to get theta by itself, we would need, to get theta by itself, we need to take the inverse sine of both sides and then divide by 2. So we take the inverse sine of both sides. We're solving for theta. So the sine on the left side cancels out, and you have sine minus 1. And this is r times g divided by v naught squared, right? And then you had the 2 theta, so this all has to be divided by 2. So you could just put a 1/2 out front here. Okay, so now if we plug in all of the values that we have, we still have 1/2. We have inverse sine. R is the range, so that's going to be 68. G is gravity, acceleration 9.8. And that's in meters per second squared, but 68 is in meters. And then, of course, this is going to be divided by v naught squared, which is meters per second squared, both squared. So all the units are going to cancel out. So we can just ignore units. So this is going to be 175 squared. Okay. You plug all that into your calculator, and this comes out to be 0.623 degrees. And that would be the angle that the hunter would need to shoot in order to hit the target from that distance away.